Last thing we're going to talk about is the design of an experiment. I may kind of skip a couple things in here. I just want to really talk about the different types of experiments that we might see. So when we are talking about an experiment, I know there's some vocab terms on your sheet. It's a controlled study to determine the effect of one or more explanatory variables, and explanatory variables can also be called factors, has on a response. Okay, so in an experiment, we manipulate the explanatory variable, and then we measure the response. So the explanatory variable could be any number of things, kind of depending on what you want to study. So let's say I wanted to know the impact, let's say I wanted to measure if it was better for me to help you review for a test in person or using a Chromebook. Okay, so the explanatory variables, I might have half of you sit with me and we review together, and I might have the other half do some activity that I put on the Chromebook. So that's the explanatory variable, the factor. Either you get the in-person review or you get the technology review. And then what would be the response that I would be measuring there? Your test scores. So I want to see who did better. Each of you in that case would be an experimental unit or the subject, whatever we're applying our treatment to. A control group. I didn't really have a control group in that scenario, but let's say maybe I divide you into 3 groups. And you guys get no test review. I'm just going to give you a test. You guys, I'm going to sit down and review with you in person, and you guys are going to watch a video to review. So my control group is the group that gets nothing, no review. And then we would be measuring to see if you all did different in comparison to them. A placebo, you guys have probably heard of that. Usually that's used like in medical trials. If you want to see if a new medication works, you might have a placebo, which is just like a sugar tablet. It doesn't do anything. But that way we can measure, did you actually get healthy because the medication was working, or were you healthier because you thought you were taking something that would make you better? So it kind of eliminates that mental component to it. All right, any questions about those terms? Okay. So some other things that we might see in our experiments, we can have single or double blind experiments. So a blind is basically when someone doesn't know what's happening. Now would there be any way that I could review for you and you wouldn't know if I was reviewing in person or through a video? No, you're obviously going to know what kind of review you're getting. But maybe I want to compare 2 different teachers for an online class. Would it be possible for you to take the class online and not know who your teacher is? Yes. Would it be possible for the teacher to teach the class and not know which class they're teaching? No. So that would be a case of a single blind. You guys don't know who your teacher is, but the teacher does. Okay, a double blind is when both sides don't know. So maybe I'm going to have you guys, give me an example, something. So a medical trial. Okay, they might have people taking a new medication or placebo. Could it be possible that both the doctor and the patient don't know which one you're getting? Yeah, there might be some third party that dictates what you get, and so that way the doctor doesn't treat you differently because they know you're getting the real thing versus the placebo. So those are next 2 terms, single and double blind. Single blind, just the subject doesn't know. In double blind, the researcher and the subject don't know. Okay. So the English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half the students receive the traditional and the other half has the online. At the end of the semester, both groups will be given a test to determine who performs better. So who would be the experimental units here? All students or just students in this class? Right, so be as specific as you can. Okay, what would be the population we're concerned with?
Freshman English students.
Yes. Okay, so my whole population, I wouldn't say all college students because I'm not applying this to everybody. I'm looking specifically at freshman English here. Okay, what are the treatments?
Traditional course and online course.
Mm-hmm. Okay, what's the response? Mm-hmm. Okay, why can't this be done with blinding?
Because they'll know which if traditional online.
Right. You know if your class is in person or online, and if I'm teaching you, I know if I see you every day or if you're online. So both sides know. So any questions about what it means for a treatment, response, those kinds of things, blinding? So the last piece is just a few different ways an experiment might be set up. So probably the most common, what we think of is completely randomized. Each experimental unit is randomly assigned a treatment. So that might be you walk in the room and I have you draw a number 1, 2, or 3 out of half. So 1 is your control group. 2, you get in-person review. 3, you get online review. It's totally random which one you get. Is matched pairs. So maybe I want to know if class review would help. So I might have you take a quiz when you first walk in the room. Then I might review with you and then give you a quiz again. And I'm comparing your scores from the first time to the second time. So I'm not comparing different groups, but I'm taking you, your individual score, and comparing the first time and the second time to see if you improved. So that's matched pairs. Your data is paired up. You're not just comparing everyone. I'm going to skip this example. You are looking at 2 things that are related. It doesn't necessarily even have to be the same person. Maybe I have you work with a partner on something and I want to compare you and your partner. You guys are a pair because you worked together. So anytime the data is paired up in some way, that's matched pairs. The last 2 options are blocking and randomized blocking. So in blocking, we group together similar people and then randomly assign within each group to a treatment. So I group you together first, and then everybody randomly gets a treatment. So maybe I think there's a difference between males and females. So I separate the males and the females, and then randomly give each of you treatments. And typically, when we're doing blocking, you'll see a randomized blocking. So it might mean I separate you guys out into males and females. And then the males, I have randomly draw a 1, 2, or 3 to decide if they're going to be the no review, the in-person, or the online. And then the females also draw 1, 2, or 3. So I'm going to separate you into groups, but then within each group I randomly assign you one of the treatments. So both males and females have all 3 scenarios, but I've separated you out and then randomly given you one. All right. Any questions? So let's just look at 1 or 2 examples to wrap up. So let's look at this one. Xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. The researcher measures the children's ratings of the 2 types of milk. So A, what is the response? What am I measuring? I'm looking at how they rate the milk. Okay, so think of some factors in the study. So factors are what? The things that are different treatments. Which ones are controlled and which one is manipulated? So what could be some controlled? So things that are probably going to vary, but I have some say over it. So I'm not intentionally manipulating that. So things that would make people different, like age, gender. Those aren't things that I'm manipulating, but they are some differences that I would have to consider. Okay, and I might want to control for that by saying I'm going to do 10 males and 10 females, and both of them are going to be kids between 5 and 10 years old. So I might control what age, what gender I'm looking at, but they are still variable. What is the thing I'm manipulating? So you get the milk with it or milk without it. Okay. What are the treatments? So that's kind of like the factors, and we have 2 different cases here. You get the milk with xylitol, or we have the plain milk. So how many different treatments are there? Just 2. Okay, you're going to come, and I'm going to give you 2 cups of milk to drink. Everybody gets to try both, but those are the treatments. What kind of experimental design is this? So is it blocking, randomized blocking? Is it completely randomized? Is it matched pairs? What would this be?
Single blind?
It is a single blind. That is correct, because the researcher knows which one they're getting. The kid does not. And this could also be considered a matched pairs. Why?
Because there's 2 responses.
Right, you're going to give 2 different responses. I'm going to give you 2 cups of milk, and you're gonna tell me, this one's better than this one. So I'm going to compare how you rate each of those. Who are the experimental units? Mhm. Why would it be a good idea to randomly assign whether the child drinks the milk with the xylitol first or second? So, why would it be a good idea to mix it up? Instead of everyone getting the xylitol milk first and the regular milk second. Why would I want to mix them up?
It could affect other, what they think of the other one.
Mm-hmm. Definitely. You know, if you are really, really thirsty, which one's going to taste better? The first drink of milk or the second drink of milk? The first one. Alright, so we need to consider that. Or maybe, you know, the xylitol tastes great on its own, but if you follow it with the regular milk, maybe there's an aftertaste or something like that that we're not accounting for. So you just want to make sure that any difference you see is because of how the milk tastes, not just the first one's always better than the second one or something like that. So let's remove the effect of order. We want to make sure order doesn't matter. Do you think it would be a good idea to double blind this experiment? Why not? Okay. What if we had a third party? So you are going to be the researcher. I'm going to sit back and I'm going to say, okay, this one is going to get the regular milk first, and then you hand it to the child. So somebody knows, but you don't know. Would that be good? Maybe. What if you are you're doing a research study and you are trying to convince people that we should be adding xylitol to the milk, okay? So if you're going to hand 2 cups to someone, you're wanting them to like the one with xylitol in it, right? That's your whole goal, is to convince people that we should be adding this. So is it possible that you wanting them to like this one might somehow influence what they say? Yeah, maybe if I'm like, try this one. Okay, now try this one. It's really good. You know, something like that, just your facial expressions, your mannerisms, how excited you might be about it could impact the response. So a double blind would not necessarily be a bad idea here. It might help control for some other bias that we might see. Any questions there? Okay, so I think I'm done. I'm not going to